welcome back. This is our second lesson of the week. This lesson is going to be a little bit longer, but I'm probably going to just put 2 lessons this week. So I want to start with our last lesson when we drew weights of different masses and we had a straight line. Okay, and what I want you to do is pick up 3 points on that line. Pick up 3 points on the line, not the dots, on the line itself that you drew. Okay. And then what I want you to do is find out the corresponding weight and the corresponding masses, okay? If we were in a maths lesson, we will say the x-coordinate and the y-coordinate. You know, any point on the graph has an x-coordinate and the y-coordinate. So the x-coordinate for us is the mass, and the y-coordinate is the weight. So pick up 3 of these points, find the weight and the mass of each one of them, and then divide them. So divide first weight by the first mass. The second weight by the second mass. The third weight by the third mass. Okay? Find the number for each one of these ratios. Do it now. Pause me and just do it now. What you should get is a very similar number. You should find pretty much the same number for the ratio between the weight and the mass. And that number needs to be pretty close to 10. Okay? Maybe a little bit under 10. Maybe a little bit below, above 10. But it's supposed to be very close to 10. Okay? If you got something between, let's say, between 9 and 11, let's say. If you got between 9 and 11, then you got a good result. Okay? Yeah, obviously, actually, we use the same data, so we should get closer to 10. Okay? So what we're finding out is when we do this investigation, we find the ratio between the weight and mass, we get a certain number which is closer to 10. Now, we call that 10 the gravitational field strength. Okay? That is, give it a little letter G. Okay? Okay? G is gravitational field strength. Okay? And as we said, it is close to 10. Okay? In grade 10, we will say actually it's 9.8, 9.81. Okay? But for us in grade 9, it's fine to work with 10. Okay? Now, what is this gravitational field strength? Let's start actually with what the units. What is its units? Okay? So weight, we know, is in Newton. Mass is in kilogram. So the unit of G, okay, we'll give it the letter G, which is the gravitational field strength, is Newton per kilogram. And if you understand what this unit means, you understand what the gravitational field strength means. Gravitational field strength is like a converter. It tells you, it helps you convert mass into weight. Okay? If my mass is 70 kilogram, that's my mass. It's not my weight, okay? Because mass is measured in kilogram. Then my weight will be 10 times that number, okay? It will be 10 times 70, it will be 700 Newton, okay? Why is the unit Newton per kilogram? Because it tells you basically how many newtons each kilogram weighs. Okay? If you've got 1 kilogram mass, how many newtons will have? That's your G. Okay? Now on Earth, because we are on Earth, close to the surface of the Earth, gravitational field strength, the G is 10. Now as I'll show you later on this week a video, okay? In different planets, the gravitational field strength is different. Okay? So if you go to Jupiter, okay, which is much heavier, more massive planet than planet Earth, the gravitational field strength will be larger. Okay? So the weight of each kilogram there is going to be different. Okay? If my weight here is 700 Newton, on Jupiter it might be 7,000 Newton. I don't know. Maybe not 7,000, but 5 times 700. Okay? Right? That means maybe I'll be like a squash pancake if I ever find myself in Jupiter. On the other hand, the moon, with the gravitational field, the G is smaller, 6 times smaller, my weight will be smaller. And that's why if I ever go to the moon, I will just walk like I'm floating, because my weight will be less. My mass will be the same, but my weight will be less. We already spoke about that. Okay, now if I rearrange this, okay, I can write weight is equal, multiply both sides of the equation by mass. So I'm going to write weight equal mass times the G field. And I'll just So if you ever want to find out the weight, okay, you multiply the mass in kilogram by the gravitational field, which is the unit is Newton per kilogram. Now, always in physics, we have an equation. We will write down a symbol equation for it, okay? So the weight, we can use the letter W, okay? Or normally I would use Fg, okay? What do you reckon Fg stands for? The F obviously is force. The G stands for? Correct, gravity. So that's the gravitational force equal M, which is obviously stand for mass, time G. And G is your gravitational field strength. Okay? So this is the equation that you'll find at the top of the test. Okay? Gravitational force, okay, or the weight, equal mass time G. Now G can take any value. It depends where you are. On the moon, it's 1.67. On Earth, it's just under 10. Okay? And Jupiter, it's probably 5 times that, something like that. So, on Earth, you need to remember that it's 10. Now, I'll require you to remember that it's 10. So, if I'm telling you I'm on Earth, then you need to know that you need to put G equal 10. But if I'm another planet on the moon, then I need to tell you what is the G, otherwise you won't know. Right, please copy that down, and we will solve some questions. Okay, so a few questions to start, okay? So the first one I kind of did, but now we'll do it, show it how we do it. So Mr. Lesham's mass is 70 kilograms. What is my weight on Earth, and what is my weight on the moon? Okay? Now on Earth, I'm always using that equation, okay? The weight, the force of gravity is mass times G, okay? So my mass is 70 kilograms. Time G, which I need to remember, guys, you got to remember that. Now on Earth, the gravitational field strength is 10, okay? 10 Newton per kilogram, okay, so time 10 Newton per kilogram, and the answer, as I mentioned before, 700 Newton. That's my weight on Earth. Now, how would I calculate the weight on my moon? Now here, I'm not expecting you to remember, so if this was a test, I will have to give you, okay, the gravitational field strength of the moon, G moon. And I'm saying here it's 1.67 Newton per kilogram. So what will be my weight? It's still going to be the same mass, okay, 70 kilograms. But now the gravitational field strength is 1.67. Okay? So for that I will need a calculator. Just pause it here for a second. Okay, fit that into the calculator, and what I got is 116.9 Newton. Okay? Normally we will need 2 decimal places, maximum 2 decimal places in an answer, okay? So 116.9, okay? You can see that even though my mass is the same, my weight is much less. That's why I will be floating, okay? Right, next question. What is the weight of a 500-gram box on Earth? Okay? So it looks like it's the same question. It is the same question, obviously. Fg, the weight of that box, will be the mass. Now, if I write 500 grams, I will make a mistake. Why will that be a mistake? Correct. I have to work with kilograms. The mass must be in kilograms. So I need to convert 500 grams to kilogram. Okay, kilo means 1,000. So there's 1,000 grams in a kilogram, so I have to divide by 1,000. There's going to be 0.5 kilograms. That's why it's very useful to write down the units. So if you wrote 500 grams, hopefully you'll stop yourself and say, hang on, I have to work with kilograms. 0.5 kilogram times 10, right? G in Earth is 10 Newton per kilogram, and then the answer is 5 Newton. Okay? So a 500-gram box will weigh 5 Newton on Earth. Right, hopefully pretty easy. Next, what is the mass of a box if it weighs 167 Newton on the moon? So now for the first time, they're actually telling me what's the weight, and I need to calculate the mass. Okay? So you need to get yourself into a habit, guys, to substitute before you rearrange. What does that mean? Okay? You will get this equation in the test. Okay? So you don't even need to remember. You should remember it, okay? Because that will mean that you will know how to use it well if you remember it. But you will get that in the test. Now you've got to ask yourself, right, which one of these do I have? Do I have Fg? What is the Fg? Is the weight? Yes, I do. It's 167 Newton. So I simply substitute. I put, instead of Fg, I put the number, which is 167 newtons. Okay? Now, M, what is the mass? I don't have the mass. I need to calculate the mass. So I don't know what it is. I'm going to use the letter N for it. Okay? Next, G. Do I know what G is? Well, normally G is 10. Okay? When we're on Earth. But here we said we're on the moon. And remember, in a test, if that would be a test, I will have to tell you what the G of the moon is. I told you here it is 1.67. I'm going to time it by 1.67. Okay? That means substitution. You just put the numbers in the formula, and that's dead easy. Okay? Only then you should rearrange. How do we rearrange? We want to find what n is, right? So we're going to divide both sides by 1.67, just as you do in maths and algebra. Okay? And n will be 167 divided by 1.67. Okay? Now we rearrange. Okay? Where is the problem? Sometimes students will rearrange the equation first. They'll say, okay, mass m equal Fg divided by g, which is correct, but often there are mistakes. So get your mark first of all for substitution. There's hardly any mistake you can do here, and only then rearrange. Now I chose easy numbers, okay? 167 by 1.67, you don't even need a calculator, is 100 kilogram, right? Okay? So the answer is 100 kilogram. Cool. I'll pause here. I want to add one or two more questions. Okay, chaps, two more questions, right? Mr. Lesham's weight on planet Zorg is 7 Newton. Calculate the gravitational field strength. Okay. Now, in a test, obviously, I will need to tell you also what my mass was, but we already had it in the last question, so we know my mass is 70 kilogram. Okay. So we want to know what the gravitational field strength on Zorg. Again, the trick here is substitute and then rearrange. Okay, so we ask ourselves, Fg, do we know the weight? Yes, we know the weight. Okay, the weight is 7 newtons. So I'm going to write 7 newtons. Do we know my mass? Yes, my mass is 70 kilograms. Do we know what G is, the gravitational field strength? It's not 10 because we're on Zorg, we're not on planet Earth. So I just write G. How do we find G? We divide by 70, okay, to get rid of the 70. So G equals 7 divided by 70, which is 0.1, and we must give the units here, okay, because we work with Newton and kilogram, it will be Newton divided by kilogram, okay? That will be the gravitational field strength on that planet, okay? Much smaller planet than planet Earth. The last question, which I think is, not harder, but just a change of units. An ant weighs 100, what is m Newton? Okay, there's two kinds of m Newton. When you have little m Newton, that means millinewton. Milli, okay, like millimeters, which is 0.001 meters. Okay, it's like 1 divided by 1,000 meters. So this is 1 divided by 1,000 Newton. Also, you have big n, that is meganewton. And that means 1,000,000 newtons. So it's a bit confusing. Okay, when you have a small n, that means milli. When you have a big n, that's mega. That is divided by 1,000. That is times 1,000,000. Okay, like megabytes. Okay? Think about megabytes as a million bytes. Millimeter is 1,000th of a meter. Okay, so again, the trick here is to use the formula and substitute first of all. So, Fg, do we know what my weight is? Yes, it's 100 millinewton. But can I just write 100 millinewton instead of Fg? No, that would be a mistake because I can see I'm working with millinewton. I have to work with newtons. So, to get it answer in Newton, I need to divide by 1,000 because we said milli is divided by 1,000, okay? So, 100 divided by 1,000 is 0.1. So, the weight is 0.1 Newton, okay? Now, that is equal to the mass. Do I know what the mass is? No. That's what I tried to calculate. So, I'll write n times g. What is g? G is 10. Gravitational field on Earth is 10. Okay? So, I want to find out what the mass is. I'm going to divide by 10. M equals 0.1 divided by 10. The mass is 0.01 kilogram. Okay? 0.01 kilogram. And if I'm a bit mean in a test and I want to, not mean, I just want to see that you can do some conversion units. If I want you to write down the answer in grams, okay? So what is 0,01 kilogram? If you want to get the answer in gram, you have to time it by 1,000. Okay? So the answer is going to be 10 grams. 10 grams. It's quite a heavy answer, I think, 10 grams. Anyway, I've written below this video a bunch of questions, okay, just to practice that equation. Use the time, do all of them. Very, very, very important, because this is the sort of thing that we'll ask in a test, okay? Right, that's it for this week. A little bit of a longer lesson, but only 2 lessons this week, so it shouldn't be a problem. I'll see you next week when we're going to move on to magnets. Cheerio.